Hey y'all, Miss Kennedy here. Let's take a look at graphing quadratics, but they're in intercept form this time. And so that's a slightly different way than vertex or standard. And it looks different because right off the bat, I don't see that little 2 exponent that says, this is squared, this is a quadratic. We don't see that. So it looks different. It's got 2 sets of parentheses. And there's just a couple of things that you have to remember. That's probably an understatement. There's probably a lot more than a couple of things you have to remember. Sorry, but it's not bad. So here's the nice thing about it. Yeah, neither one of those is the nice thing about it. Okay, here we go. So it is intercept form because it tells you right off the bat what your intercepts are. You have x-intercepts at 5, 0 and at 3, 0. Now look at the problem, look at what I wrote, think about how I got that, right? So if it says x minus 5 here and x minus 3 here, that kind of gives us our intercepts. That's saying, if we were to solve x minus 5 equals 0, x minus 3 equals 0, if you think back to when you had to factor and solve and you got down to these factors and then you had to set them equal to 0 and solve. And so if we add 5, we're going to get x equals 5. And if we add 3, we're going to get x equals 3. Okay, so that's kind of where that comes from. And so I can go over here, 1, 2, 3, 0. That's one of my intercepts. And 5, 0, that's another. So I know that those are 2 points on the graph automatically. Like I already have 2 points. And what I need to find is my vertex. Now my vertex is going to be halfway between those 2 points, which is kind of cool. So on here, it's, to me, and I think to you, it's probably going to be pretty simple to go, okay, if these are my outside points, halfway in between would be here at 4, right? Now that's not where the point's going to be. I'm just saying that's that halfway point, right? And so sometimes it's easy to see, sometimes it's not. So for the vertex, what we would do is we're going to add those 2 together. It's called P and Q. Just go with it. We're just going to add 5 and 3 and divide them by 2. We're finding the average. We're finding the halfway point between the 2. So 5 plus 3 is 8. 8 divided by 2 is 4. That's exactly what we thought it would be. So that's the first part of our vertex. Okay, and why did I add 5 and 3? Because that's the numbers here. That's our x-intercepts. And we add them, divide by 2 because we're finding the average or the halfway point. Okay, so now to get the y value, we're going to do what we did with standard form, and that is to plug in a 4 for those x's and see what y is equal to. So we're plugging in a 4. So I have, and take this over here. So I have negative 1/3 times something minus 5 times something minus 3. And I want to plug in that 4. So 4 and 4. Okay. So 4 minus 5, that's a negative 1. 4 minus 3 is a positive 1. So I have negative 1/3 times negative 1 times positive 1. So negative times negative is positive. So that's a positive 1/3. Okay, so the rest of my vertex is 1/3. So that tells me that I'm going to go over here and go right 4 and up 1/3. So just try to estimate, that's about 0.33, repeating, so 1/3. And so about, I should say. All right, so it's just up a little bit, just a tad. And we've got pretty well our graph here. You're probably also going to have to say whether it opens up or down. We can see that it opens down, but let's confirm that. Let's go back to the equation and make sure that we didn't graph something wrong. Maybe we graphed weird and we've missed it. Maybe we got the vertex wrong or something. This is a way to check that so we don't miss it, because we didn't take the time, take this 2 seconds to look at this, because it really is 2 seconds. It's going to be super quick. We're going to look at the a value, that number that's right after the equal sign. In this case, it's negative 1/3. A is negative 1/3. And if it's negative, then it opens down. So our graph is good to go. We're great as far as that goes. And the last thing that you're, pretty sure you're going to have to write is the axis of symmetry, which is always based on your x value from your vertex. So again, x value of the vertex is 4. And that's just saying that if we bring this ruler over here and we get ourselves a nice dashed line that runs through x equals 4, we can see that we have that line of symmetry, that the points on the left are symmetric to the points on the right as far as their height goes. And that's it. I hope this helps. Thanks.